Our project basically is we're building a deep learning model to be able to forecast rainfall in the southeast US, basically forecasting of the very near future. So something basically 12 hours or less in the future. But we're trying to get a very accurate prediction, rain and other storms in the area in the southeast US.
Most of the flooding events, they are caused by the extreme rainfall in 6 hours. So we want to develop a deep learning model that achieve a balance between the computational cost and also the accuracy.
The unique thing about climate data that they use very complex models like FureNet. This is my first time actually working with these models. I learned a lot from working with radar data set. ZDAR gives us insight to the shape of the rainfall, and DBZ also is basically the intensity of precipitation.
There was a lot of difficulties at the start that we eventually figured out, and then we started kind of making quick progress.
Our models was taking very long time for training, so it's very long time.
Part of the reason is that we're using a too large data set. But to solve that question, the student thinking about using the distributed computation with multiple CPU and GPUs. So this can largely improve the efficiency of the computation.
We were able to make very good predictions for 40 minutes in the future. We had an evaluation score, which basically just tells us how good was our results. It was around 76%. But for longer forecasts, like 3 hours or 6 hours, the results started to fall.
Of course, we can use this model trying to save the time and also save the money to make short-term forecasting so that we can make a better or less costly warnings about the extreme rainfall and floodings in this area. They are so highly motivated and they learn all they can do to reduce the cost. So they find this way using the distributed computation techniques as well as using the GPU to accelerate the computation. And also to learn some basic knowledge of the meteorology as well as the weather forecast. So before that, they know nothing about what is a radar for and how radar detects the precipitation. But after that, they can tell the broader audience like how did the radar collect the raindrop sizes and the rain amount from the different radar bands. I think that is also a very interesting question because we are translating the meteorology knowledge to a broader audience.
Yeah, learning things is always really hard. So right now I try to learn how to deal with those models and how to understand those models and how to read the essays that introduce the model. And that's the really big accomplishment for me. The climate field is like a really small field, and a lot of people are still using the traditional method to do the prediction or stuff like that. So I actually feel that I'm doing something. I'm improving the academic field.